Hi there. Open Refactory provides a family of services designed to provide application security or AppSec defense against increasingly sophisticated attacks on your open source software. In this video, I will show how Open Refactory's root cause service, offered as part of Open Refactory's Project Clean Beach, works. A vulnerability is defined by a CVE. To set the context, let me first explain what this service does. You provide the CVE to Open Refactory's root cause analysis service. From the CVE information, the RCS locates the source code and analyzes it to determine the set of functions or methods that, when executed, will manifest the vulnerability. This result is returned to you as a JSON file. An example will show how this works more clearly. Consider the CVE with the following ID, CVE-2026-24061. This is the critical vulnerability in the Telnet D daemon that allows remote code to be executed as root. Note that this CVE has a criticality score of 9.8, quite high. Let's examine the CVE in more detail. The problem is in the utility.c file in line 1736. This is in the var shortname function. The problem is in the auto-login feature that was added 11 years ago. The vulnerability has remained hidden all these years. Now let's see how the Open Refactory root cause service handles this CVE. For this CVE, we will send the CVE ID to the root cause service. We are expecting that the result will return the var shortname function as the root cause. The communication is done using a private GitHub repo. From this repo, we open an issue named CVE Submission. An issue template is provided to help you to give your input. Your input may be a single CVE or a list of CVEs, each in a separate line. Our example vulnerability, CVE-2026-24061, is entered. Creating the issue will trigger a job request to the Project Clean Beach root cause service. You will also receive a GitHub-generated message confirming the successful submission of your CVE. Within the Project Clean Beach service, the RCS authenticates with GitHub to gain access to the same GitHub repository. From there, GitHub Actions cause the example CVE to be read and for the analysis to begin. The root cause is determined, followed by triage and verification to generate the highest quality data. The results are stored in the root cause folder of the GitHub repository. The root cause is stored in a JSON file, one for each version of the affected artifact. To locate your results, connect to the shared GitHub repository again. In our example, which is CVE-2026-24061, you first go to the root cause directory, which represents the package ecosystem, and click on the folder beginning with deb. This is the short name for Debian used in the Perl. The deb folder contains the 2026 directory, which comes from the first part of the CVE. This is followed by the 24061 folder, which comes from the second part of the CVE. Then the directory structure follows the GAV, or Group Artifact Version format, of the Perl. You go inside the group folder, which is Debian in this case. Then you go inside the artifact folder, which is inetutils. There you see the folders of the different affected versions. Inside a version folder, you find a JSON file that contains the root cause information for that version. The JSON file contains the root cause function, var shortname, and also a short explanation regarding why it was identified. A simple script can be used to navigate the directory hierarchy and fetch the information programmatically. The information can then be used to create Bech documents, generate internal advisories, or some other purpose. If you want further information on the root cause service, or want to learn more about how Open Refactory can assist your AppSec defense journey, please contact us at info@openrefactory.com. And thanks for watching.